Now you can use it for revision if you do it too quick. So, algebraic fractions. We've already done lots of work on how to deal with fractions. So we've got keeping fractions equivalent by multiplying the top and the bottom, or dividing top and bottom by the same amount. We've got adding fractions. What do you need to do when you add fractions? Make the bottoms the same, make the denominator the same. How do you multiply fractions?
Multiply the numerators and the denominators.
Yeah. Multiply the numerators together, multiply the denominators together. How do you divide fractions?
You switch the second one.
Yeah. Switch the second one and then multiply. How do you simplify? Factorize and
Factorize it.
factorize, then cancel out the common factors. When you cancel out common factors, do they disappear?
No.
They become 1. Thank you. Okay. Now, with algebraic fractions, what I prefer to do is show you exactly what is happening rather than give you a shortcut. So, we're going to stick with those rules. Fractions, you can compare fractions with the same denominator. All right. You multiply tops, multiply bottoms, you cancel out. We're going to use all of those, so I'm not going to give you anything new. We've just got to be able to apply it. So I've got this algebraic fraction here, if you want to write that one in your book. So 2 over 5x minus 2 is equal to 3 over 6x plus 1. Okay? Now, some of you may go, right, cross multiply, right? But I want to give you a different way of thinking about it, because quite often when we just do shortcut cross multiply, it leaves you with a little bit of uncertainty in some places. Now the thing about fractions, let me give you a piece of something to think about. If I said 2 over 3 is equal to something over 3, what can you tell me straight away? A equals 2. Why is that? Because the denominator is the same, right? So could I go from that and just write 2 equals A and kind of not write the 3's? Okay. Now, have I done anything with the 3's?
No.
I've just decided that they're not part of the problem anymore. I don't need to worry about them. I'm trying to solve the bit I'm trying to solve. Okay. In the same way, what if I wrote 3 over 8 is equal to 3 over B? Can't. B has to equal 8. Again, same thing. The 3 is the same, so the 8 and B have to be the same. Now it changes slightly if I do this.
Now you have to multiply.
Why? Why are you saying 16, which is great? Why? Okay, so what you're telling me is, well, let's manipulate this one so that we have a similar situation here. So if we times by 2, we get a 6, but this has to stay the same value, so we times by 2 again, which makes 16. Now we've got a like numerator, therefore the denominators have to be the same. So 16 has to be B. Does that make sense?
Yeah.
So it's that whole principle. Now I need to, do you want to write that down, or should I just get on with the...
Yeah.
I need to delete it, by the way, so
Yeah.
I can just get rid of it?
Yeah.
Okay. So that's the principle we're going to use, rather than think of cross multiplication. So, if I say, so I'm just going to rewrite this, 5x minus 2 is equal to 3 over 6x plus 1. Now, can I make the numerator or denominator the same value, therefore not have to worry about it? No? Well, the denominator is that's where the fun's happening, so kind of that's the difficult bit. What about the numerator? Is there any way of making the 2 and the 3 have the same value? Nice and easy, isn't it? So actually this one needs to be multiplied by 3, which if I do that, I have to multiply this one by 3. So I'm going to put 3 brackets. Okay. So that keeps this the same, so it's an equivalent fraction. And this one needs to be similar, but 3 times 2, so I have to do the same to the bottom. So we then end up with 6 over 3 times 5x minus 2 is equal to 6 over 2 times 6x plus 1. Alright. What do you notice now? Say again? Well, we can make a statement first. We've got it to a situation before we worry about doing anything else. What can I now say?
The numerators are the same.
The numerators are the same. I know that because it's 6 and 6. But more importantly, the denominators are the same. So could I now forget the fact that they're in fraction form at all and just write 3 times 5x minus 2 is equal to 2 times 6x plus 1. Are you happy with that? Now they're not on the bottom of a fraction. I'm just making the statement that says if the numerators are the same, right? So 6 equals 6, therefore the denominators have to be the same. So I can then put 2 separate equals rather than the one in the middle. What I've done now is I've got rid of the fact that it was a fraction at all. Make sense? Now we haven't solved it yet, obviously, but we have solved these kind of ones before. But that's the important step for me. So what I'm going to do is I'm going to come back to this one, so leave yourself a gap to actually solve it. But we're going to carry on talking about this fraction stuff first. Give you think about that. So say we're going to solve that one. We're going to come back to it, but we're going to have a look at another question first. Everyone all right with that? Right. So got a different situation here. If you want to write that one down. So what I'm going to do. We've got 2 parts to this. We've got this left-hand side, which is a subtraction of fractions, and then we've got equals and amount. Okay. There's actually several ways to think about this. What do you think we could do with the subtraction of fractions first? Do the subtraction. Okay, we have to do that first. How do we do that? What do we need to have done? Make the denominators the same. So you've looked at that. If we take that separately, 6 over x minus 2 subtract 6 over x plus 1. How do you do that subtraction? How do we get the denominators the same? We'll put it in brackets.
X minus 2 times x plus 1.
Yeah. So I'm going to spread mine out a little bit more. So I am going to multiply this one by that denominator, because that makes the denominator x plus 1 times x minus 2. And then this one I multiply by that. So now the denominators are the same. But obviously, to keep the fractions the same, the top has to be also multiplied, doesn't it? So the top also has to be multiplied by x plus 1 minus, and this one has to be x minus 2. Okay. Right. You can see there's a lot of marks for this question, by the way.
Yeah.
Be quite a few steps. How can we actually then do that subtraction? Well, we've just added stuff in. If we cancelled it out, we'd undo what we did.
We have to expand the bracket.
No, we don't have to expand brackets. Remember, when we're dealing with fractions, we want it in factorised form, which means we want it in the brackets.
And teachers at the bottom. We just said it, we can raise our back.
Yeah. Well, we've got a subtraction to do, haven't we?
Mm-hmm.
So when you subtract, what happens? The denominator, we only have one of them, x plus 1, x minus 2. And what ends up on the top? This subtract this, no?
Yeah.
So then we have 6 times x plus 1 minus 6 times x minus 2. Now what do we have to do? Now we can sort the top out. We can expand and simplify. So what does that lead us to? So expand those brackets for me.
6x plus 6 negative 6x plus 5.
Good. That's the tricky bit. The negative times a negative. I'm glad you spotted that. We've still got the fraction. That's minus 2. And then if we collect like terms, we end up with 6x minus 6x is
0.
brilliant. Love it. Got rid of the x's. Plus 6 plus 12 is 18. So we've got 18 over x plus 1 and x minus 2. Okay. So we've done the simplifying the fraction bit, but we've still got to do the equation bit. Is there any questions on that stage at the moment? No, that's all. You're all happy with it. I mean, it's quite a high-end question, this. So if you're finding it a little bit difficult to keep track, not a problem. It is quite sort of the top end of what we need to be able to do. What we need to do though is go back to sort out this equals 1. So I'm going to rewrite it up here. I'm going to now write it's 18 over x plus 1 x minus 2 equals something. Okay, so I've got equals 1 here, but I need to do something to be able to solve. And I'm going to, there is several methods to think about this, but the one I'm going to do is the whole trying to make the fractions on either side the same. Yeah, like we did with the other one. 1, however, is not a fraction, but it could be. What is 1 as a fraction? 1 over 1. In fact, 1 is anything over itself, yeah? So that's what I'm going to use. And I'm going to then pick, there's actually a couple of options, to make it very similar to the one on the left-hand side. Yeah.
If you do the x plus 1 and then the x minus 2 on the bottom.
Perfect. You can do, I've got 2 options here, you choose. I can have x plus 1, x minus 2 over x plus 1, x minus 2, because although that looks really complicated, because the top and the bottom are the same, it equals 1. What statement can I now make? Well, the denominators are the same, so I can now say that 18 equals x plus 1 times x minus 2. Okay, so I've got rid of the fractions now. The other option was, instead of using that, what could I have used? 18. But I would have ended up with the same thing. I would have had 18 and 18, and then 18 on this bit equals bottom. So I'd have ended up exactly the same place. So that's how we get rid of the fraction. So lots of steps there, lots of work. That's why it's worth 5 marks. Well, we haven't solved it yet.
What exactly are we trying to find?
Well, when you have to solve, what does it mean?
Find X.
Find x. But what have we got now? We've got to expand these brackets. I'm actually running out of room. Can you expand those brackets for me? Something you need to be able to do in your test? X squared
Plus X
plus x
minus 2X.
minus 2x minus 2, which simplifies to
X squared plus minus 1. What did you minus X?
minus x minus 2 equals 18. But, go on then.
Would you plus the 2 on the main?
Right, well, you can, definitely you can. You don't want to. Because when you solve a quadratic, what do you want to equal in?
0.
0. So you don't want to plus the 2, you want to
Minus 18.
minus the
You have
18.
to put this in the
So we-
formula.
There you go. So x squared minus x minus 20.
And then you have to put it in the formula?
You don't actually. You could.
About to say.
You could put it in the formula. Alright? So we've got a quadratic equaling 0. What are our 2 options for that?
Negative b.
So we could use the formula.
Split the middle.
We could split the middle term. But when you're splitting the middle term, you're trying to do what? Factorize. Yeah? Now actually, when we factorize, this one, although it looks like it might be tricky, it's actually quite easy. Because we've got x and x. Now it's 2 numbers that multiply to make 20 and then add together to make minus 1. So numbers that multiply, 4 and 5, straight away. One of them's got to be negative. So it's got to be negative 5 because the middle is negative, therefore the bigger one's got to be negative. And we've got plus 4. Lucy was there, straight, spotted that. So what are the solutions then? X equals and x equals, do you remember?
Negative 5 is 1.
Not negative 5.
X minus 5.
X minus 5, if it's these two multiply to make 0, one of them's got to be 0. So either x minus 5 is 0, which means x has to be 5, has to be the opposite, or minus 4. So there are your 2 solutions. Yeah.
Why did you get, where did you get 0 in Japan?
Where? Here, at this bit here. Because what Leah spotted was, at this stage, we had to do something, and we had to make this 0. So we subtracted that 18 to make the 0, which means we needed to subtract the 18 from here too, which...
Oh.
Question?
How did the X get 5 in
Okay, are we with us? Leah's asked the question, how do we get the x equals 5 and x is minus 4? So what we've got here is if 2 things multiply to make 0, so a times b makes 0, for 2 things to multiply to make 0, you know that one of them has to be 0. Has to be 0. The only way to make 0 with a multiplication is to have one of the numbers be 0. So that means that either x minus 5 is 0, or x plus 4 is 0. That's why I wrote a 0 there. So for x minus 5 to equal 0,
that times 0 times that would equal 0. But on the other hand, you have to make that 0
Yeah.
times x minus 5.
I know x is 5 because 5 minus 5 makes 0, and here minus 4 plus 4 makes 0. Okay? Okay, let's so I just want to, I've given this next one here. Can you see how that's the same idea? Yeah? Alright, same idea as the one we've just done. So I won't do that now. All right. Equaling 2 is slightly different though, isn't it?
Yeah.
Yeah.
She's greater than
My tip is for this one,
that.
yeah, but it's how do you turn 2 into a fraction? So it's 2 and times 1 over 1. So as long as you've got the same top and bottom again with the 2 on the top, you're all right. I'll let you, not now, but I'll let you work on that one. If you don't mind, what I'll do, I'll go back to the first one and solve, alright? I'll post this video, and maybe you can do this question 3 as part of your revision rather than do it now.
Yes, that's fine.
And then we can get on with the third stuff. Alright? Because I think, unless you really want to do it now straight away.
No, let's do that.
Right, let's go back to this one then, and let's finish it off. Alright? So, we got to the stage of we no longer have a fraction. Can someone just recap for me how we did that? What was the process? So we made we made the numerator the same, and then we multiplied the numerator by 3 and then the denominator by 3 because that keeps it at a what? What's it called? An equivalent fraction. So we do not change the values of either side by multiplying the top and bottom by the same value. And that's important because we have an equal sign in the middle. You can't change the values separately when you've got an equal, you have to maintain it. So we did that and we ended up with just that the denominators must be the same. So how do we go about solving this? I'm just going to write it down here. Well, actually I won't do that just yet. What do you do? What would be your next step here? Expand the brackets. So what would that be? Alex, would you like to talk me through expanding? Would you like to talk through the expanding the brackets? So 15x minus 6 plus 2. Good. Alright? So now we're in this situation where you've met before, just the simple linear equations, unknowns on both sides, just like you solved with the other one, but that was harder because it was quadratic. What do we do this stage, Leah? So I'm going to subtract the 12x from both sides. So can I write that result first, rather than do it all in one go? So that leaves me with I'm not doing, by the way, I never do 2 operations in one go. Some of you do, well, I'm going to subtract the 12x and then add the 6 at the same time and write it all in one line. Feel free to carry on with that, works for you. I never do, so because I like to be able to check all my steps. So now I add 6, 8. Okay. X equals. Yeah. So that would also be 2 and 2/3. Is that the answer we did?
No.
Yes, it is.
Yes, it is. Well, we asked for a decimal.
And which it won't. Do you know why it won't? What does the question start with? Fractions. So the answer is quite happily going to be a fraction. And plus, do you know, actually you should now be able to tell me what that decimal is without a calculator.
Really?
Yeah. Because it's 2 whole ones, so 2 points.
66.6 recurring.
There can't be another point. You can only have 1 point. So it's like 2 points, and then you have the fraction. So it's 6, 6, 6, 6, and so on. So you could write 2.6. Do we know why it's 6, 6, 6, 6, 6? Because 1/3 is 3, 3, 3, 3, 3. So if you double that, you get 6, 6, 6, 6, 6. Okay. That that or that as your final answer. In this question, it just says, solve, show your algebraic working. It does not specify what the answer must be, right? And it will say 8/3 or equivalent, right? Well, actually, if you have your calculator, all right, this would be they do show clear algebraic working. So if you use your calculator, you wouldn't get full marks. But is there a way of showing one function equals another function?
Yes.
How?
No.
What do we do to find when two functions are equal to each other? Yeah, we could do simultaneous equations. Because one equals another, therefore. I was thinking more of graphing. Because we could take that one and do y equals that. And then do that one and y equals that. And you just find where they cross. Yeah? And they'll cross once and you can get the answer. But that's not the method they're expecting you to use. But it is you could check your answer. What I would say, if you've got really ridiculous numbers coming out, like strange looking fractions, you've probably done something wrong. They'll end up with relatively simple.